In our previous video, we coded the parts A through E, where we prompted the user for a function, and then we got the upper and lower bound, we plotted the function, got the error, and then we got the actual value in quotes with the VPA solve function. So now in this video, I'm going to go ahead and show you how to use the false position method to program that algorithm. And then also what I'll do is I'll show you how to print it out in a nice table that shows you the various steps of this. So it's going to show you the lower bound, the upper bound, the actual false position result, and then the error between the actual as well as that approximate value XR. All right, so looking at our MATLAB code, this is where we were at in the last video. So now what I'm going to do is I'm going to start by printing the table out, or the header. All right, so I'm just going to do an fprintf statement, and I'm going to say our iteration, and then I'll say our XL, lower bound, and then our XU for our upper bound, and then I'll get our XR, and then finally I'll have the error. And then I'll do a /n to jump to the next line. All right. Now, when this prints, we're going to have to do some doctoring on this after we're done because it might not be spaced correctly. Okay. I'm going to say I equals 1, and that's going to be our counter for our iterations. Okay. So this is just going to basically be how many times this has gone through. And now what I'm also going to do is I'm going to figure out, if you look at our formula, I need to figure out the function evaluated at the upper and figure out the f at the lower bound. Okay, so I'm just going to do a subs function to be able to figure that out. Okay, so I'm going to say, I'm going to call it f low. Okay, so the function at the lower bound, that's going to be subs into r, which was the original function up here that we got from the user, comma x, comma low. That was the value that the user also put in. And then I'm going to say f high, the function at the higher value, is equal to subs. And I'm going to say r comma x comma high. All right, so that's our f high and f low. And now what I can do is I can actually compute xr. Okay, and that's our formula that we're going to use right here. So that's going to be xl times f high minus our high minus f low. So it's almost like a quotient rule from derivatives. And then we divide by the function. All right. No, by the way, this has nothing to do with our quotient rule whatsoever, at least on surface level. So that's going to be for our formula. That's going to be our low times f high minus our high times f low. And we're going to divide that by f high minus f low. Okay. Now I'm also have to figure out what the value is of the function at xr. So I'm going to call that fxr. And the reason I need to do that is because if you look at our algorithm, the algorithm says that we need to replace based on what xr is. So if xr is less than 0, then xl becomes xr. If xr is greater than 0, then xu becomes xr. And then in the very unlikely scenario that fxr is actually equal to 0, then we're done. All right, so let's go back, code that. So that's going to be a subs. So f of xr is a subs into r comma x comma xr. All right. And then now what we can do is we can actually compute the error as well. So our error is going to be equal to the absolute value of xr, which is our guess, minus the actual. And remember in the previous video, we got actual with the VPA solve. We're going to divide that by actual. All right. So now what we can do is we can go ahead and do the if statement, and we're going to do this part where we do the substitution back in. Okay, so if it's less than 0, XL becomes XR, etc. So let's program those three conditions using an if statement. So if XR is less than 0, then we're going to say that X and the low is going to become XR. And then else if XR is less than 0, just hit enter by accident, then we're going to say that the high becomes XR. And then finally, else if, for some reason, if XR is exactly 0, then what's going to happen is we just say that we found the 0. Okay, so we just do an fprintf, and we say the 0 is %f/n, and it's just going to be the value of whatever xr is. Okay, and that's going to be very unlikely that we have that. All right. Now, last thing I'm going to do is I'm going to print out everything that's in this header. Okay, so this is our algorithm right here. Okay, and then I'm just going to go ahead and do an fprintf, and I'm going to say %d, and that's going to be the iteration. The first %f is going to be the xl. The second %f is going to be the xu. And then the third %f is going to be the xr. And then finally, the last one is going to be our error, /n. And then in that order, we have I, comma, low, comma, high, comma, xr, and then error. Okay. All right. Now I'm going to give this a run at this point, because if all this is good, then all we have to do literally is just cut and paste the large majority of this code and put it into a while loop. Okay, and that's pretty much how a lot of numerical methods work. You just make sure that the first iteration is sound, then you put it in a while loop just to make sure that you meet the error condition. All right, so we're going to run this. And if you recall, the function that we're looking at is expx minus x minus 3. All right, and remember the graph is going to come up over here. Okay, so we should have some sort of 0, right? And we're going to say that's from 1 to 2. Okay, and let's just say 001, right? And then here we are. Here's our iteration. Now we are going to have to play around with this a little bit for the spacing, but that's not that big of a deal. Okay, so our algorithm looks sound. We're at roughly a 10% error just by one iteration. To fix the spacing, what I'm going to do is I'm just going to put some spaces here, and then I'm going to run it again. All right. A trick you can use is you can just copy this, because that's probably going to be like the thing that you probably just use the most, and then run it. And then you can just paste it in here. That way you don't have to just keep typing the whole thing over and over and over and over again. All right. And now I can just go ahead and backspace a couple. So I'm just going to backspace this a few times. Maybe space out the XU that was up here. So it's just a game of spacing things out. All right. It's not that big of a deal. I'm going to run it again and see what happens. All right. And then because it looks good, the last thing we're going to have to do is just put it inside a while loop. And then we'll be done with this. All right. Backspace the XU a little bit. And then backspace the XR a little bit. Let's try it one more time. And then at this point, it's just cosmetics, just running it a few times. So just trial and error. I'm sure there's a nicer way to do it, or you could probably use like a built-in function, but maybe just too lazy. Okay, that's pretty good, right? That looks okay. If I really wanted to be picky, which I am going to be, I'm going to space the XR and then backspace the error. That should look pretty good. All right. So now that I know that a numerical method is sound, because at least we get an error of 10%, what I'm going to do is I'm just going to make a while loop. And I'm going to say while our error is greater than, and remember we had the user error. All right, so this user error that was put in here. So while the actual error is, what I'm going to do is I'm going to copy and paste all of this stuff. Okay. The only thing I'm leaving out is the I. All right. And what I'm going to do is I'm going to fix that when I'm in here. Okay. So I'm just going to go ahead, paste that in there. All right. This is annoying me. My computer science teacher would be happy. And then I'm going to say I equals I plus 1. All right. So I'm just incrementing the counter every time. Remember, this is the number of iterations. At the very end here, I need an end statement. Right. Now I'm going to go ahead and run this. And I'm going to type it in again. Right. And then it might take a minute because I have to graph the function. There it is. Here's a 1, a 2, and I'll say 0.001. All right. And it looks like it's just keep going on forever. It looks like that I didn't update the error. Okay, so let me break out of this with a Control-C. it looks like the error every single time is going to be the same thing here. All right, so um, let's see what happened here with this. Did I cut and paste the error? XR. So this should be replacing. Oh, I see. It's right here. This should be greater than 0. All right. That was just a logic error, like way back here. All right, no problem. Fixed. And then over here, I probably should have just looked at that beforehand. So probably just typed in too fast or something, but regardless, all fixed. So xpx minus x minus 3. I'm going to copy this just in case I have to go through and do another round with this. All right, there we go. All right. For some reason, MATLAB likes to skip down. I don't know why. All right, it kind of just it does its own thing sometimes where it skips around. But sometimes if you run it a couple times, it kind of just remembers what's going on with things. So I'm just going to run this one more time. But our algorithm's definitely solid at this point. Yeah, I don't know why. It's just thinking pretty hard. But you can see right here that we're at an error of 0.08%. Okay, if I was to move this, or 0.08%, yeah. So that's really good for us. Okay, so that's how you can go ahead and program a pretty easy numerical algorithm to get to a specific error. Okay, so again, key things to remember is what you want to do is you want to put the table before you do any sort of computations. All right, and you want to find the actual value if at all possible. All right. So basically what you want to do in the first step is you want to always get all the data, okay, that's needed. Then what you want to do is you want to figure out what your header is. So your header and your counter. This might be just like a good algorithm for you to use. And then what you're going to do is you're going to do one iteration. Okay. And then once you have that one iteration correct, then what you do is you just copy and paste that iteration. So copy and paste the algorithm. In a while loop. Okay. And that's probably like an easy way for you for going on subsequently for a lot of these assignments where I'm going to ask you to program these numerical methods to make sure that you're able to do in that fashion. Okay. So that should take care of everything in this section. And you can probably go ahead and work on your assignment at this point.